Okay, we are live. So I'm going to go over the Unit 4 practice test. As a reminder, when you guys are doing your real test, these numbers might be changing from question to question. So when you go from this question here, which will be the same question, talking about rubies and emeralds and plain stones, but it might say 8, 4, and 7, and then this one right here, it might say 7, 6, and 12 or something like that. These numbers might change from question to question. I have it set up with multiple questions for each one, and every time you or your friend or me, if I go through it, you're probably going to be seeing slightly different numbers. Okay, there's over 700 versions of the test if you consider the different options. Okay, all right, so this first question is just plain basic probability. Okay, it says the probability of randomly selecting a ruby given that there's 10 plain stones, 3 rubies, and 5 emeralds, and they're all the same. Okay, I know it's magic. Okay, 5 emeralds, 3 rubies, and 10 plain stones are never going to have the same shape, size, and weight, but we're in a magic world, in this theoretical math world. So on a question like this, it's just simply, what do you want? You want rubies. So there's 3 rubies. Okay, dividing by what's the total amount of stones you have here, right? Or gems, 10, 3, and 5. So 3 out of 18. If I use a calculator and say 3 divided by 18, I get this number right here. Now I'm letting you know on the test it's multiple choice. Okay? Don't worry about rounding because there's only going to be one answer that probably looks similar to that, And when I do these problems with rounding, it's going to be to the 10,000ths place, right? It's going to be 4 digits. So just be advised on that. Any questions on that one? This should be like middle school level probability. Okay, but now by the time we get to the end, this is like college level statistics, right? All right, so question B. Probability that a randomly selected rock is not plain. So you have 2 options here. The obvious one, the one you might have heard, a couple of years ago, would be to say, well, if this is plain, those 2 are not plain. So 3 plus 5 is 8, right? And 8 divided by 18, again, will give you the answer. But I'm going to show you a way to think about it from a little bit slightly different perspective, and that different perspective is supposed to be kind of what the big objective was, okay, for this kind of basic stuff, was to kind of train you to think a little bit differently when you see the word not. So when you see the word not, you should be thinking 1 minus. Okay, 1 minus what? 1 minus plain. And it's like, what? I thought you said not plain. Yeah, 1 minus plain gives you not plain. Okay, 1 minus plain gives you not plain. So plain is 10 divided by 10, 3, and 5, once again, would equal to 18. Be advised, when you take your test, A and B might have, there's a good chance they're different numbers. Okay, not always, but depending on the version that you get, those 3 numbers might change from A to B. Okay. So once again, 1 minus 10 over 18, you don't got to do this stuff in your head. It's going to be some crazy number probably. Just do, calculator. And I'm using Google Calculator, or the calculator from Google. I like it because it's got every feature that I need for this class. At least right now it does for this kind of stuff. And it does order of operations for you. Okay, if you're using like a different calculator, like a handheld calculator, sometimes those calculators do not do order of operations for you. The Google calculator does. Okay, so one more time, this way of thinking is to say what's plain, which would be 10 plain stones out of 18, right? 1 minus that would be not plain. Questions, comments, concerns right now? All right. So here we go. Question 2. Suppose probability that a Serrano senior has a driver's license is 0.51, which to translate this to basic English would say 51% of Serrano seniors have a driver's license. Okay. A job, 0.23. Once again, in more common language would be 23% of seniors have a job. Okay. And both is 0.15, which translated to basic English would say 15% have a driver's license and a job. So this 15% is part of both of these groups. Okay, this isn't a driver's license without a job. This is not a job without a driver's license. This just says 51% have a driver's license and 23% have a job and 15% are both. Okay, so they want to know the probability of this kind of stuff. Once again, for your test, please be mindful. There's going to be 3 questions like this, and with each question, these numbers might change. They might be the same. They might be the same numbers for those 2. It's just be mindful. Okay, be mindful that you might have to do, you know, a number of scratch work for the same problem with slightly different numbers. Okay, just be ready for that. So we have 2 groups, right? Driver's license and job, and there's some overlap. Start with the overlap, start with the overlap, start with the overlap. Okay? Then fill in these spaces right here. Go to the driver's license, okay, or go to the job, either one. I like to go left to right. They told me driver's license first, so I put it on the left. That's why. And if it's 51% or 0.51 probability, we need to take away the 0.15. Okay, so 0.51, take away the 0.15, gives us 0.36. Okay, so those 2 added together, okay, which is the driver's license only with a driver's license and a job, okay, that gives us the 0.51. So starting from the middle helps us get that 0.36 pretty quickly, right? And likewise for the job, if it's 0.23, take away the 0.15, and that would give you the people with a job without a license. So 0.23, take away the 0.15, the remaining number is 0.08. So be mindful, okay? You can do this kind of stuff in your head, but I recommend just verify. Take the 5 seconds to use a calculator, because sometimes we see that and go, oh, I know 15 and 8 is 23, so you put 0.8, which would be 80%, okay? So please, if you're not fully confident with this stuff, or even if you are, me included, okay, I like to double check with a calculator because I'd rather be right. Sorry, there's people that are quick and people that are right. And a lot of times, sometimes if you do it quickly, you're not right, okay? So be mindful of that. Now, every probability is 100%. Every probability, sorry, every time you have something with a probability, it should always add to 100%. There's people with a license, there's people with a job, and there's people with both. There's a 4th group, people that don't have a license or a job, right? And that is this outside group. And so what I like to do before I answer my questions, okay, like I know these questions are going to require me to use these numbers, right? So I like to start, take a moment, and say, 1, take away, and I'm going to add these numbers across. I'm going to say 0.36, take away 0.15, take away 0.08, and the remaining value is 0.41. Okay, and you can kind of write that anywhere in this outside circle. But this whole box here, in this book, in this class, they've referred to it as what's called the sample space. Okay, and this outside sample space, well, sorry, the whole thing is a sample space, but this is like the remaining outside people, right? This says 41% don't have a license or a job. Okay, you just can't like subtract it from those numbers because remember there's that weird group that's in the middle. All right, so now that I've kind of set up my problem, right? If I add all 4 of those numbers up, it should add to 1, which is like 100%, right? So what I'm going to do now is just go down the line and answer these questions. Now, on your test, you might have to do this for each question. So this really only takes about 30 seconds to a minute. Let's just say it's a minute. That's 3 minutes of your test, okay? I don't think it's that much work, okay? And if you got issues with that, let me know and we can try to work something out, okay? All right, so a driver's license, but not a job. That's those people, right? They're part of this circle only. They're not part of that circle, right? They don't overlap into this job circle. So a driver's license only is 0.36. Question's done. Next question. Either a job, a license, or both. You see that word or? Okay, that means to add up all this stuff. You see the word or, right? Either a job or a license or both, okay? Remember, in probability and statistics, if you think of the word or, you should be adding. If you think of the word and, or it says the word and, right, you should be multiplying. So this is an or type statement, so it is adding. 0.36 plus 0.15 plus 0.08, okay? Be mindful of the 0.8, and we get 0.59. And then last but not least, neither a job nor a license, which we already figured that out to be 0.41. And remember, when you do your test, when you might do all this work here for question A, but then all of a sudden you get to question B, and those numbers might change to like 59 and 18 and like 12 or something like that. So you'll have to do some scratch work and make another box, make another Venn diagram, and fill the numbers out again with those new numbers. Okay, like I said, it takes a minute, but if you want to get the question right, take that minute to do the scratch work. Okay, have a pencil, have a pen, whatever, have some scratch paper and work the problem out. Have a calculator up. Use Google Calculator, okay? And then once again, when you get to question C, it might go back to the first set of numbers. It might use those numbers again, or it might be a whole new set of numbers, okay? But they'll all be the same kind of question with the same sort of close values. Like they'll be off by like 5 or 10 hundredths. Okay, questions right now before I move on.
Mr. Annaberry.
Yes, ma'am.
How did you wait? Why did you do the box?
Why did I do the box? When you see a question that gives you probabilities like this, this is a Venn diagram problem. You have, well, you can have more groups of people, but this is just two groups of students at Serrano. You have those that have a license and those that have a job, okay? And like any other good Venn diagram, there's a mix of both in the middle, okay? Which is, in this case, 0.15, okay? So we always kind of start from the inside out. We start by talking about, we know both is 15%, okay? However, we were told that people have a license. Well, that's 51%, right? 0.51 probability. So if you take out the job people, this circle is 0.36 and 0.15. Add it together, make the 0.51. So that's where I took the 0.51, took away the 0.15 and 0.36. So this says it's 36% of the students have a driver's license without a job, because we know 15% have both. So take out that 15%, and that leaves us with just the 36% that's only driver's license people. And the same is true for the job people. This says 23% have a job. Okay, but knowing that 15% have a license and a job, we're able to deduce that that's 8% only. So a reminder, you got 23% have a job, take away the 15 have both. The remaining amount, 0.08, are people with a job but with no license. Okay, so what that leaves us, though, because remember, all probabilities add to 1. Okay, if I select a random senior at Serrano, some might not have a license or a job, right? Let alone both. And so what we have to do is finish out the entire sample space. This entire sample space, all of our numbers should add up to the number 1. The number 1, right, is 100%, because we have all of our seniors together add up to 100%. It has to. All these probabilities, all these numbers should add up to 1. So there's a few ways you could do that. You could take 0.36 plus 0.15 plus a 0.08, and then say 1, take away the last answer. Next, oops. My favorite way to do it is to start with 1 and then just subtract across. Subtract the 0.36, subtract the 0.15, subtract the 0.08, okay? And that says the remaining amount are the Serrano seniors that don't have a license or a job or both, obviously. Okay, and that's 41% are just vibing without a license or a job. Now, why did I do it like this? This is the recommended way to work this problem out. Okay, it's kind of like if you had like, let's say $13.18 plus $126.74. You're like, oh, if I add that together, what do I get? Can I just add it like this? Like this would be like my preferred method to add these together, right? Line up the decimals, put the number on top, do this business here. Okay. Like this is how I would work it out. I mean, you might work it out a different way, but this is like my preferred method, right? On a problem like this, when you see a question where you have two groups of people with some overlap of the two groups, right, with both, and you want to know the probability of this and that, and answer these kind of questions, the recommended way to work that out is by using Venn diagrams. Okay, so why did I draw a box around it? I drew the box to like basically say, here are these seniors. All the seniors I'm going to put inside this box, and I'm going to put them into groups. Some have a license only, some have a job only, some have both. But I understand that's not all seniors. There are seniors that don't have either of those, that don't fit in those categories. Therefore, I put them outside the circles, but still within the box, okay, of all Serrano seniors. And that would be the 0.41 probability, or 41% of all seniors. Did that clarify it?
A little bit.
Okay. So for right now, Miss Russia, I'm going to move on. But if you have more questions, I will be available for tutoring today from 2 to 3. Okay? All right. So for time, I'm going to go ahead and move on to the next question. I'm going to go on to question 3. Now with question 3, like I mentioned before, I'm not going to ask you guys to upload any pictures or do anything weird stuff like that. It's going to be just straight multiple choice. All right. When I do that, this part right here is not going to be part of your test. However, you should do something like this to work out the numbers so you can answer these questions. Okay, well, particularly this question. Once you get this question, you can answer this question. However, yeah, there's no explanation to it, okay, because it's multiple choice. However, just know you're going to get some numbers. Those numbers are going to help you to find this answer here. When you go to this question, these numbers are probably going to change. Therefore, you got to use this whole model thing to work out your values for this question here. Okay, so you'll have one set of numbers for the first part, and there's like a 2/3 chance that you're going to have to use different numbers for this second part of the question. You might not. It might be the same numbers, but it's more likely for a majority of students, over half the students are probably going to see a different set of numbers for the second question. Okay, so just be mindful of that. So by probability model, this is what I mean. Let me read the question off and try to clarify it. It says you buy a one-time cost insurance plan for a new video game console. If your device stops working completely, it will cost the company $500 to replace. Okay, I like to kind of underline this kind of stuff, right? If your device is a small failure, it costs $220. So I'm going to double underline that because to show that's different. You've got a replacement for $500 or just a repair for $220. Okay. Now, I notice to replace it, that's a probability that the device will fail completely. That has to be completely replaced. But to be repaired, I'll double underline it to show the connection of the cost to repair it. So cost of repair is $220 with a chance happening in 3 in 35, and a 1 out of 800 is a $500 replacement cost. So there's 3 things happening. 1, 2, 3. Either a full replacement, which costs $500, and there's a probability of that happening, which is 1 out of 800. There is a replacement, which is $220, which has a 3 in 35 chance in happening. And then last but not least, it costs no money, if it's not broken. Okay. Now, what's probability for that? For right now, I just don't care. It won't actually impact the problem. So if I was to ask you to make a model, I would want that number. And all you would do is just say this number right here. You'd say all probabilities are 100%. So take 1, take away 1 out of 800, take away 3 out of 35, and that would be the number that would go here, about a 91% chance. So like 91 out of 100, or 913 out of 1,000, or whatever the heck that fraction number would be. Okay? I don't care about the fraction number. It's irrelevant to answer those questions. Because what we're going to be doing is we're going to be multiplying this times this. You're going to be multiplying this times this, and then this times this. You're going to multiply those numbers across. Okay? And 0 times anything is just 0. Okay? Okay. So $500 and 1 out of 800 gives me, so 500 times 1 out of 800. You don't have to put parentheses, just the way the math works out. Okay, it's 5 times 100 divided by 800. Gives me 62. I'm going to round it up to 63 cents. So for every video game console sold with an insurance plan, they say it will cost the company 63 cents per video game console. That's not too bad. But for that costly repair of $220, okay, for that costly repair of $220, it will cost the company 3 out of 35. That will cost the company $18.86. So for every device sold, knowing that 3 out of 35 need repair, knowing that $220 is the cost for that repair, every console that goes at the door with an insurance plan will cost the company $18.86. So the expected amount they will pay per insurance plan, you have to add those numbers down. This plus this plus this is your average amount, your expected amount for every insurance plan. So 63 cents plus 1886 gives me a total of 1949. So when that video game console goes out that door, okay, that new Sony PlayStation 7, that new Xbox Series 1 X 360, whatever, or that Nintendo Switch Wii U, every console walks out the door with an insurance plan, they expect that it's going to cost them on average about what, almost 20 bucks, right? Most of them won't cost them anything, but out of 800 consoles sold with an insurance plan, it's 500 bucks for them to replace it. For every 35, 3 of those will cost, 220 bucks. And with video game consoles, you look it up online, you can look at the video game console sales, and they're in the, millions and millions and millions and millions of consoles sold. So they're going to make some money off this stuff. Right. If the console costs 500 bucks, but it's going to cost the company back almost 20 bucks, they'll eat that cost every day. You know what I mean? They're still making almost $500, or they're still, selling those things for 500 bucks. So that's how you would solve this first part of the question. Now, when you get to this next part of the question, double check your numbers, because those numbers might change, and you'll have to do this again for this new question. So don't use this answer, or don't expect this answer to be done for this question here on your test. There's a more than 50% chance that those numbers will change. It might not. Okay, but if you're using scratch work, then you'll already have your answer from the previous question, because you're not going to be allowed to go to your previous questions after you answer your question. So have scratch work, write the stuff down. Just write it how I write it. It doesn't really take that long to write that stuff down. Okay, follow the systems and the diagrams how I do this stuff. Okay, there's a reason why I write stuff like this. Okay, so oh, Miss Garcia, you're fine. All right. Colin, I see your face right now. Can you help me out, sir? So if you know it costs the company $19.50 per insurance plan sold with a console, what would you expect to be a price they should charge?
$25.
Okay, that was the answer that I put on the answer key. Could you give me some bad options? Because it's going to be multiple choice. So what would you predict would be a bad number?
I'm just like $3.
Okay, that's a great bad option. Give me two more.
Can I do like really high, like 50? that
You
good?
could, but I would say try to make it obvious. Like $3 was obvious, right?
Mm-hmm.
I'm going to try to
Okay.
make sure that there's no gray area on this test. That when you do this, there's going to be one obvious answer that just seems very reasonable, and three that just seem like if you did the work, it's going to be obvious that they're obviously bad. So give me two more options.
$9.
Okay,
And 11.
cool. So what do you notice? You notice that if it's going to cost them almost $20 to repair your stuff, like on average per payment per plan, if you charge a little bit more, they're actually making money now. So not only are they making money off the consoles, they're making money off the insurance plans too. They're a business. They like money, right? It's Mr. Krabs here, okay? They like the money. So this number, whatever you get when you solve this stuff, and once again, be advised, those numbers might change for this question, so you might have to recalculate this estimated amount again, or this expected amount again, bump it up a little bit, and look for that answer for a multiple choice thing. The other ones, the other values on your multiple choice should obviously be wrong. I'm just going to leave it like that. Okay, there should be three obviously wrong ones because they're going to be losing money per insurance plan, but some will make money. Okay, I can go on the whole insurance plan stuff and how that kind of stuff works. Usually it's third parties. Usually it's not the manufacturer. Usually it's some third party that makes money off this stuff. They do these cost analysis to make sure that they don't lose money. Okay. Unless the company just screws up and they make a bunch of bad machines and all of a sudden the insurance company is like, wow, thanks, good job. You made us lose. That is not cash money. That is not diamond hands. You know what I mean? All right. Questions, comments, concerns right now? Okay, so the biggest issue I see is students not paying attention, doing all this work here, getting the answer for this one. They click next on the test. They get this question here, but they're not paying attention how those numbers might have changed. This might be 600. That might be 150. This could be 1 out of 400, and that could be 2 out of 7. Okay, and all of a sudden you just got to multiply this and this, multiply that and that, add them together. That's your new number for your expected value. That's all you got to do. This times this plus this times this. Just calculator work. 500 times 1 divided by 800 plus 220 times 3 divided by 35. Hell, I mean, what the heck? Oh, I put 22. I'm like, that seems way wrong. 500 times 1 divided by 800 plus 220, don't forget the 0, times 3 divided by 35. Yeah, there's that $19.49 again. Well, granted, that's 48 cents because this is this one I rounded. The answer on the screen right now is not rounding, okay? But it's multiple choice. Don't stress it. It's not going to be that. I'm not going to have them off by a penny and try to screw you up, okay? But please, please, pretty please double check, triple check the numbers before you move on from this question to that question. You're not going to be able to go back and look at your previous answers. That's the way the test is set up. All right. No questions. Moving on to this last one. Now, this last one, once again, for the original practice test I uploaded with the answer key, there was some mistakes on it. Okay. I apologize for any confusion. That's just one of those things to show you that this is a difficult kind of question, and it takes a lot of practice. If we were in the classroom and we had 5 hours a week to do this, we would do more practice in class. I'm not going to lie. That's the benefit of being closer proximity and, it's expected when I assign homework to you guys practice it. And if you have questions and don't know how to do it, then come to tutoring, look it up yourself, go through the book, whatever you got to do to find resources to try to learn the material and at least take notes so you can, at least perform well on a test, the best of your ability. I think it's question 25 in chapter 16 homework that talks a lot about this kind of stuff, and it's about tennis. Me and a student spent about 20 minutes at the end of the last class period going over it. So I know that this kind of question is part of your homework. So if you haven't done the homework, or you did it but didn't understand it, then this question here is, might kick you in the butt. Okay, this question here got me confused because I just wasn't feeling 100%, and it just kind of kicked me in the butt because I did something I thought was right, and I screwed it up. Okay, but I'm going to fix it right now. I'm going to show you exactly how to do it and exactly how to get 100% on the test. Okay, so some information you need. We're talking about strikes here, right? Just understand with baseball, a pitcher throws to a catcher, and there's a batter trying to hit the ball. And that pitcher, when they throw it, they've got a certain area they have to throw it in, and if they make it in that spot, it's called a strike. If they don't make it in that spot, it's called a ball. Okay, so I'm kind of assuming you understand a little bit about baseball or softball. Okay, very, almost the same exact rules, and they follow those kind of rules. So our success of getting a strike is, for this problem, is 75%, which we would say is 0.75. Expect for your test is going to be something like 60%, 70%, 80%. I'm not going to do any weird numbers like 1 or, any weird, 63.47%. I'm just doing straight up easy numbers. Okay, just the basic concept of this stuff that you could then apply to more complex values, but I just want the basic nice and easy. Okay, so your failure is 1 minus the success, okay, which is 25. Okay, once again, that number is 1 minus your p, which is 1 minus 0.75. Okay, that's how I got my failure. Okay, that's success, that's called your failure. Basically what you want, this is talking about your strikes, this is talking about the balls, that's your failure. Okay, what you want, what you don't want. Now there is one more number in here. And that's 7 pitches. So I'm going to put it to the side. N equals 7. Okay, that's going to be an important number in this problem somewhere. Okay. So in the first question, we're only concerned about the first 2 pitches, but 1, 2, 3, 4, 5, 6, 7. Okay. I don't care about those other ones. I don't care about pitches 3, 4, 5, 6, and 7. All I care about is his second pitch is a success. But the first pitch had to be a failure because his first strike wasn't on the first pitch, so it's got to be a failure. So the second one was a success. So what I have here is just Q times P, right? The first one's a ball, and then the second one is a strike. It's not or, it's and. So that means multiplication. So I'm going to say Q times P, which is 0.25 times 0.75. Okay. If it was like Q, 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 P, I would say Q times Q times Q times P, or Q to the third power times P. Okay, so take a look at how this kind of works. This says the second pitch. So the first pitch would be a ball or a failure, a Q. The second pitch was a strike, which is the success, which is the P value. When I multiply those together, I get a probability of 1875. Okay, so the probability of getting what you want on the second attempt. This is not asking about anything about the third, fourth, fifth, sixth, seventh attempt. For this first problem, you should ignore that stuff. I'm going to sharpen my pencil for this last one because it's going to require some detailed work. All right. So once again, please be careful. Please be mindful. When you go from this question to this question on the quiz, you're not going to see these numbers again. Okay? There's a greater than 50% chance that this number here might go from 80% to 60% or 60% to 70% or 90% or whatever number is there. So please double check your percentages and your end value. Okay, and then this number right there is going to be used in this next one. Okay, so if you think about it for a moment, there's 7 pitches that are thrown. 1, 2, 3, 4, 5, 6, 7. This right here says he gets at most 5 strikes. So that would be like getting a success, a success, a success, a success, a success. So 5 strikes and then 2 failures. Okay. Now you have to consider those 5 strikes probably weren't, I mean, they could have been the first 5 pitches and then 2 pitches that were balls, right? I mean, think about it. You could have 5 successes in a row with 2 failures, or it could have been 2 failures with 5 strikes after, or these values could be mixed up anywhere around, right? These failures could have been anywhere in this sequence. So to consider all the different variations of that, out of 7, we're choosing 5. That's that thing that looks like this, okay? Or like that 7, choose 5, okay? That was that thing that said 7 factorial over 5 factorial times 7 minus 5 factorial, which would be 2 factorial. Okay, remember that? But this says at most. So guess what? We would then add 7, choose 4, right, of like P times P times P times P times Q times Q times Q times Q. Like this is one of those things, right? It would be 7, right? Choose 4 of 7 factorial over 4 factorial times 3 factorial. Okay, that's the formula. This is a little formula to basically say, I know that 4 strikes in a row with 3 balls afterwards is not the only way to arrange 4 out of 7 strikes. It could have been in any order. It could have been 1 strike, 2 balls, strike, strike, ball, strike, strike, or whatever. Like you could rearrange that in how many different ways. That's the math equation to figure it out. Okay, so like that first one, for example, would be 7 factorial divided by parentheses 5 factorial times 2 factorial. So these two numbers here should always add up to that number up there, okay? Because this number down here, remember the formula, they gave you, they said NCK. I think in regular algebra class, they call it NCR, okay? But in this book, because R with statistics usually means something different, they like using the letter K because it hasn't been used yet, okay? And they said the formula would be N factorial over K factorial times N minus K factorial. So these two numbers here add up to the top number every single time, okay? So I would do this all the way down the line where I'd go 5, 4, 3, 2, 1, all the way down to 7, choose 0. So that basically you've got, you know, you've got 7 Q's. You got Q to the 7th power, okay? And you would do every single one down the line. And in fact, that's where I made the mistake, right? That's where Mr. Atterbury and his being a little bit tired and stuff, I kind of did it wrong. I was trying to do the shortcut method, and I said, you know what? I don't feel this is right. And so I redid it, and I did it the long way. And when you do it the long way, you have 7 choose 5 times success probability to the 5th power, the Q probability to the 2nd power, and I went all the way down the line for 7 choose 5, 7 choose 4, 7 choose 3, 7 choose 2, 7 choose 1, 7 choose 0. This would be the probability of X being less than or equal to 5, okay, where your N equals to 7. You do 7 choose 5, 7 choose 4, 7 choose 3, all the way down the list, okay? But when I was trying to do the shortcut method, what I did, I kind of screwed it up, okay? I said, oh, well, I know there's 5, so that means if there's 7 pitches, that means there's something about 2, right? Because 5 balls, sorry, 5 strikes, 2 balls would make this. And I made a mistake. I'm so sorry, guys. So when I thought about it a little bit more, once again, I knew the answer the long way was this. Okay, there's no way you should mix up 98.5% with 55.5%. Those percentages, those probabilities are way different. Way different. So what I kind of didn't really consider, I kind of forgot about, was what do we want? We want 0, 1, 2, 3, 4, 5 strikes. What's not part of that group? 6 strikes and 7 strikes. So X is greater than 6. That was the actual one I should have done from the get-go. So you could do this, like I said, 7 choose 5, right? Because it says at most strikes. So probability of X being less than or equal to 5. And then I would do this, 7 choose 5, yada, yada, yada. It would look something like this. I'm going to show you guys a shortcut in a moment, because that shortcut, I think, is going to save everyone a lot of time. So it's the success to this power times the failure to the remaining, right, 5 strikes, 2 balls. But you got to remember, it's not going to be in that order. I mean, it might be in that order, but you got to consider all the different combinations. And you're going to add that all the way down to 7 choose 0. And then the success is going to be 0, no successes, right? Because no strikes would fit this thing, times the failures, okay, which is 7 balls, okay? So you would do this, and that work would look like this. Like, that's a lot of work. That's a lot of opportunities for errors, okay? And how the heck do you do this in a calculator, right? It would be that times that, okay, times that, okay? That's just the first one. And now add that to 7, choose 4. Like, it's insane. Like, it takes a lot of work. So that's why we have this more shortcut method, okay? This says at most 5. So here's the strategy and the best way to explain it, okay? So on this question, the same question on your test, you could do it the long way, but I'm going to recommend the more shortcut way. And take your probability, and you see how it says less than, greater than? I'm sorry, less than, equal to? Flip it. Take this less than, greater than, take this less than, equal than, and switch it. Okay? And for this problem, since there was 7 pitches and at most 5, the ones we don't want are 6 and 7. So X is greater than 6, which implies 6 strikes and 7 strikes. So if I can figure out this amount right here, take that away from 1, that'll be the same answer as this one. The reason is because adding all those together fills in 1 spot, right? And then the remaining spot is that little guy right there. And I take that away from 1, and that's going to be my answer. So the reason why we do this method instead is so I don't have to do a bunch of work. It's still some work, but it's a lot less. So I'm going to say 1, take away X is greater than 6 for this scenario. So that means 7 choose 6 times 6 successes times 1 failure. Why is it 6 successes and 1 failure? Because I'm considering 6 strikes in 1 ball. The 7 choose 6 says that 1 ball in this problem, right, out of those 7 pitches, could have been the first pitch, second pitch, third pitch, fourth pitch, fifth pitch, sixth pitch, or 7th pitch. I don't really know. I'm going to consider all possibilities. So by doing 7 choose 6, which would be 7 factorial divided by 6 factorial times the difference, 1 factorial, gives me just 7. Okay? And I'm going to add that to 7 choose 7. Okay? Remember, I don't want 6 strikes. I don't want 7 strikes. My question said at most 5 strikes. So I want to calculate those and then take them away from 1. And that's the shortcut method, because this method seemed like it was going to be a lot of work. And this way, they say, is a faster way that hopefully leads to more accurate numbers, because by doing less work, by doing less math, okay, less operations, okay, like doing all this stuff might lead to some errors because there's so many little things to keep track of. This one still is a lot of work to keep track of. It's just not so bad. So what I like to do is go ahead and do this whole statement right here, and I'll show you what that looks like, okay? So if you use Google Calculator, which I recommend because I'm showing you how it can do it right here on here, okay? Like this right here, it's going to look like 7 factorial divided by parentheses 6 factorial times 7 minus 6 is 1 factorial times 0.75 to the 6th power times 0.25 to the 1st power. So I'm kind of showing you what the calculator will look like. Okay, I'm gonna go ahead and write this out. I'm gonna actually write it out by hand. Why not? Let's do that. And then 7 choose 7 would be 7 factorial divided by 7 factorial times 0 factorial, which that just equals 1, times 0.75 to the 7th power times 0.25 to the 0 power. Okay, if I type this whole stinking thing into the calculator, which looks like a lot, but I'm telling you, this is only 2 of them. This is only 7 choose 6 and 7 choose 7 with those probabilities. Imagine if instead of doing 6 and 7, okay, you see how it kind of matches up like this? Okay, 6 successes, 7 successes. When you have 6 successes out of 7, it means there's only 1 failure. Okay, 7 out of 7 means there's 0 failures. The original problem wanted you to consider 5 and under, which it would have been 5, 4, 3, 2, 1, and 0. It would have made this problem look like that. So I did it the long way just to get the answer, and then I was like, okay, you know what? That's much faster. Whew, here we go. 1 minus parentheses. I'm going to type in this whole long string there. And before I hit submit, I'm going to double check all my work. Now, for the exponent in Google, it's that little x to the y. Okay, it's a little button next to the 0, x to the y. That gives me a little box there which says I want 6 successes, so I want my p-value, 0.75, to the 6th power, times my failure, my q value, to the 1st power. So you can put 1st power. You don't have to, because 1st power doesn't do anything to a number. Okay, and then I'm going to add that to 7 choose 7. So 7 okay, and then this times the success, which 0.25 to the 0 power is just 1. 7 choose 7 is just 1, but doesn't matter. Regardless, type that in, and I get that lovely answer. So what does that say? That will round to a 1 there at the end. This says the probability of a pitcher who throws strikes 75% of the time without fail. What's probability out of 7 pitches they throw at least, they throw no more than 5 strikes. They throw 0, 1, 2, 3, 4, or 5 strikes. They say it's about 55.5% that they'll throw 5 or less strikes. Okay, that means about 45, 44% of the time they'll throw 6 or 7 strikes. That's pretty cool. Good job for them. Holy cow! Holy guacamole! I know it's a lot of work, but once again, please be careful. Okay, please be careful that you look at your P and Q value before you start this problem, because the P and Q value, there's a good chance, will be different from this question to this question. Okay, there's a good chance it might be like 50% for this one and like 60% for that one. And so what you have to do is do them independently. Look at this question for this one and say, cool, I got my answer. Okay, then you'll get the question again. It's going to look the same, but there's a, like I said, there's an over 50% chance that this number is going to be different for this one down here. Okay, so pay attention to your p-value. Okay, that's your p-value. Your q value is just 1 minus that number. Okay, translated as a decimal. And now pay attention to this number 2. Okay, see how it says at most 5? 5 out of 7. Okay, 7 choose 5. Out of 7 pitches, we're choosing 5. At most means 5, 4, 3, 2, 1, or 0. So you don't have to do the 1 minus if you do the if you just count down from this value. But I'm letting you know now, by counting down from this value, like 7 choose 5, 7 choose 4, 7 choose 3, or whatever your n and your choosing value is, your k value, it's going to be more work to do it to count down. It's almost faster, or it will be faster to say 1 minus and then go one number up and count up. So if it's 5, you would go 6, 7. Okay. If your n was like 6 and this was like 4, it would be 5, 6. Okay. Like you just count up, but you take that number away from 1. Whew. Okay. And it's a beast of a problem, and it's recommended that you, I guess I don't need a block here. It's more of a regular parentheses. So it's recommended. I would recommend take this and see if you can't write it out like I did. Okay. Then because this is like the calculator. This is what Google Calculator looks like. Calculator. Okay. So I'm going to pause right now. The video is done before it gets too long. And then I'll answer any questions, okay? Oh, almost pushed the wrong button.